SNIFFDRONE, drone-based environmental odour monitoring. Malodours produced by wastewater treatment plants are an expanding concern as cities surround these facilities. Malodours degrade citizens' quality of life by undesired odour exposure and nuisance and may negatively impact tourism. Current odour assessment methodologies use costly and infrequent olfactometry measurements involving human panels and continuous monitoring of few gases using fixed gas detectors installed on the plant. This leads to odour measurements with low temporal and spatial resolutions that do not allow for accurate characterization of the odour emission events. In consequence, current state-of-the-art does not allow proper monitoring of the plant from an odour management point of view. The main purpose of the SNIFFDRONE project is the creation of a drone with olfaction capabilities to provide spatial dense odour measurements and autonomously localize the source of odour nuisances in wastewater treatment plants. This development involves many research challenges. The first one is to design an artificial olfaction system able to estimate the odour intensity as perceived by humans. For that, we have developed an electronic nose based on an array of chemical sensors with sensitivity to different odorous compounds and artificial intelligent algorithms that convert the high-dimensional sensor data to the odor intensity value. The system is lightweight and power-efficient to be carried by a drone. The e-nose signals are continuously recorded and sent through the radio link to the base station. The second step of this project is the integration of the e-nose into a drone, together with a sample collection system to calibrate and validate the predictions by the electronic nose. The sampling device, which operates under the lung principle, allows us to collect sample air into 10-liter sampling bags upon reception of a command from the ground station. The odor intensity of these samples, which is determined after the flight by dynamic olfactometry, serves as ground truth for building and validating the e-nose predictive models.
One main challenge of this application is to avoid the downwash from the propellers that would otherwise affect negatively the sensor readings. We solved this issue by designing a pumped system with a long sampling line that hangs vertically from the drone.
With the acquired measurements, the drone is able to produce three-dimensional maps of the time-averaged odour distribution, revealing the odour emission hotspots.
Providing real-time odour information to managers will help to make fast decisions and to apply actions preempting potential inconveniences.
The obtained odour predictions can also be combined with atmospheric dispersion models to predict emissions outside of the plant. In a medium-term future, it is envisioned to apply SNIFFDRONE to monitoring of odour emissions from a variety of sources, like landfills, composting plants or agriculture applications, largely improving processes management and drastically improving the quality of life of people living in proximity. In the longer term, SNIFFDRONE will encourage implementation possibilities of artificial olfaction systems in broader areas, with a strong impact in environmental monitoring research. SNIFFDRONE, drone-based environmental odour monitoring.